this module, the major outline of this one, you will be walk between the cloud models like public and private and hybrid cloud, what these are, some of the examples, which one you pick up, what is the decision making factor, benefit of using the cloud, and then considerations, IaaS, PaaS, and SaaS, what is the meaning of it, and who is going to responsibly maintain that. So that's what this overall module is all about. So if you check out the book of AZ-900, the official one, it would be having like 40 to 60 pages on this, which I'll be clearly mentioning for you. The cloud models, that's the first one we can go with. Now let's see what is cloud computing, public cloud, the private cloud, hybrid, and then comparison between these. Number one, what is cloud computing? So very simple question. The answer could be that today, if you want to imagine a concept, like you just think about it. It's a very interesting thing if you imagine. Think that you need an application in your mobile phone that you're using. You see, you have your mobile phone in which you install applications like Facebook, Twitter, or games, or it could be any application today we have. Now the question could be like, where it is running. Definitely most of you know the answer. It could be running in a server. That's the answer which we mostly have. Now it is going to run in a server, which is going to be a computer, which will have a network connectivity, which will have a lot of security rules and everything, which could let you to use your mobile phone and access that application, or use your laptop and join to the session using the GoToMeeting tool and all these. The same thing comes to the line when you speak about the word cloud computing. Everything is same except the fact that servers, which I said as a computer in which you host your applications, it is not being managed by you. In fact, you don't see that computer, or you don't physically touch the computer, which means somebody, anybody who's saying that we are selling cloud services, that particular somebody, they will have a physical location which is called data center, which will have servers which are given with power supply, which are given with cooling mechanism, which are given with physical security, which are given with virtual security and everything, where on demand anybody can go and say that, hey, I want a server with 10 GB of RAM and 2 CPU core to host an application. You make a request and they will charge from you for what you use, and you pay money and you host your workload. That's what cloud computing is. So mostly people who don't know what is cloud computing, the common answer that I can see from them is that it's like storing your data in cloud. That's not the answer. It's that you're using computers of somebody or services that are developed by somebody, and you're paying for what you use. That's what your cloud computing could be. Now, in a simple word, they give you compute, which is like a computer, CPU core, RAM, and all these, or networking, which is going to help you to connect your servers to internet or any other network connectivity to access your application. They give you storage, which means you can store the data of your application and all the other components. You take your Amazon Prime, you take your Netflix or Hotstar, you stream your data, which is like an OTT platform in which you see movies and all these. So that data which is stored, which are some examples where that storage components, they are given by somebody else. Or you take analytics, where you do some data analysis and come with some analytical decisions. For that, they give you services which will let you to get the job done. So cloud computing is nothing but somebody is giving you servers for rent, where you use the servers, which is your computer of CPU core and RAM, pay for what you use, and that's what cloud computing is. Now, let's come with the different cloud environments we have. One is public cloud. What is public cloud? In a simple context of this one, public cloud is something where anybody can use it. Let's take an example. A public cloud, in a simplified word, the CPU core and RAM, which I said as a data center, where somebody like Azure or AWS or Google Cloud Platform, they purchased the physical office, they maintained CPU core and RAM in a rack. A rack is nothing but something that looks this way. I'll just show a picture now. So this is how a rack looks like, something like this, which is inside the data center. You can see it. Most of you could have seen this in your office as well sometimes. So this is a rack, this vertical thing, this entire vertical thing is a rack, and this entire view is an internal view of a data center where they have power cables, network cables, and then cooling mechanism. All these are connected. So typically, when you speak about the performance factors of the cloud, that is what is a public cloud, there comes your answer. Those CPU core and RAM, which were I discussed now, those components, they are given by somebody. So those somebody are what your Azure or AWS or Google is, where any customer, you, me, so and so, somebody or some person else, they can purchase a subscription, which means they can get an account in that public cloud platform, and they can now rent these servers, which is CPU core and RAM, and use it in a secure way and host the applications from public internet or any other mechanisms. That's what public cloud, which means it's very simple. These servers are given to anyone. Anybody can use this cloud, which is open for anyone. So you can take your debit or credit card, sign up an account and use it. Or your office can purchase a subscription from Azure or AWS and use their servers. And that's what public cloud is. Second one is private cloud. Let's say what is private cloud. Same, it's same concept. So whatever I said now, the CPU core and RAM, which is vertically available as rack, it's same concept, but this time it will be only for you, which means for my office, there will be a particular data center where my office manages it or some other company manages it with the servers inside, but those are only for me. So let's say if this is organization ABC, then only organization ABC can use it and host their applications. Third party people, let's say XYZ wants to get an account in it or use it, it's not applicable. So private cloud is something that you develop for yourself within your environment, or it could be somebody develops it but gives it only for your usage. That's a private cloud. So organizations which doesn't require or do not like their servers to be shared with some other customers, even though they get security, they might have some logical issues like compliance and all. So they don't want their servers, physical servers, to be shared with some other company or organization. In such case, they prefer to go for a private cloud, which means servers are not managed by you. Some other customer or some other company could manage it, or even a different branch of your organization you might have, those people could manage it. At the end of the day, it's only for you. No other company can use it, but you can host your applications and everything into those servers and make your users to use your application. So that's your private cloud. So this is more secure because it's only you who will use it, not third party companies. The third one, hybrid cloud. What could be a scenario? Let's consider like this. Take your banking sector as an example. Now, a banking sector, they don't have any rights to take their databases to cloud because it's a very secure DB. Okay, that's cool. Now, what if we think about a case like this, where the database of a bank, they want to maintain it on their private cloud, which could be like the cloud servers, which are given only for their office, it could be, or it could be even a scenario where all their servers are in their office itself and their database is maintained at office. You can take anything. Let's say you can take an example like their DB servers are in private cloud. Now, the front-end web application, the internet banking web application, to give the benefit of cloud, which is unlimited scalability and etc., they might think about hosting the website alone in the cloud platform. Let's say Azure in this example. So now the website will be in cloud, but the DB is in on-prem. Now website and cloud connecting to your DB in on-prem in a secure way, where a public cloud and a private cloud, which is combined together, or a public cloud and a on-prem data center connected together, or it could be any other mechanism of comparisons. That's called a hybrid cloud. So an application that runs in cloud and some application runs in your private environment, where you connect them to each other for some business regions. That could be your hybrid cloud. Now, simplified comparative part, a public cloud, what is the benefit? A private cloud, what is it? And hybrid, what is the benefit in comparative way? In a public cloud, there is no capital expenditure, which means a capital expenditure in a simple word. If you need 10 GB RAM and 10 CPU cores of a server for a server, you don't have to pay money for 10 GB RAM and 10 CPU core of physical components that you have to pay in the market if you want to purchase. You say that I need 10 CPU core and 10 GB RAM, the cloud service provider will give it to you. Now you have to pay money for total hours you're going to use them. So the pre-purchasing of physical components or spending some money to get the components is not there, which is a benefit. So it's very easy to deploy your applications and make servers to scale, which means to increase their size from 10 CPU cores to 100 CPU cores in a simple time period. And moreover, you get the benefit where you pay only for what you use. And moreover, this public cloud is resolved and it's evolved in a very long way where plenty of crowdfunding they get. So a lot of research they have where they provide a lot of best components in the market to add value to your business. Whereas private cloud, in this scenario, there could be some scenario where there is a company who is completely built and ready, so you don't have to pre-purchase the hardware components. Then in that case, there might be no capital expenses. But most cases, it will be that you who have a private cloud requirement, so you will have to, support a startup, or it could be some other company who is already in the market, but you need to provide a capital investment to them in prior. So they will purchase the physical components for you, but they will maintain those servers on behalf of you, like power supply, cooling, short circuit in the data center, that management, everything they will do for you. But the benefit again, you see, since it's a private, which means all the servers are only for you, you have complete control and compliance, so no other customer will use your server. So any problem happens, it's typically you who are responsible for management, because at the end of the day, whoever your customer or whoever your organization who manages the cloud server for you, they will be responsibly maintaining everything. But most probably, if you see the performance and all the factors, a private cloud give you more compliance and benefits. And third one, hybrid cloud. So in the event of hybrid cloud, it's very flexible one. Reason is that since you have the benefit of public and private cloud in same place attached together, you can take a decision whether I want to host my workload in cloud or in on-prem, and how the compliance of an organization could be achieved. And I'm using cloud when there is an application like a banking DB, how do you plan with that? All these becomes easier since there is a complexity management with the public as well as private cloud. So organizations that have a lot of security and compliance terms and legal issues to use cloud at the same time they want to use cloud, they can go for an architecture of a hybrid cloud platform. So this is your business model of three of them, like public and private and hybrid cloud. So guys, are you able to follow me? Just mention that. Are you guys able to follow me? So Anthony, the advantage of AWS over Azure, I'll discuss this little later probably. This is because I think it's something you're just starting now. Maybe in later some part I'll mention the answer for your question. And meanwhile, others, am I clear until now? Please confirm. So
Yes, you are
Pushkar,
clear.
I'm in TCS. Okay, thank you. I'm in TCS, no experience in Azure. And then Kshitij Mehra, some knowledge in Azure. Anthony, Azure. Okay, cool. Thanks for the responses. Well, getting back now, cloud benefits and considerations. Now, what could be the cloud benefits? Those are what you're going to see, like the concepts of high availability, scalability, the agility, the disaster recovery, the concepts of capex and opex, and what is the concept of consumption here, we'll see. These are simplified benefits, but the word could be simple, but these words, they have a very good business value for you, like high availability. So today you can see Facebook. Of course, yesterday, I think yesterday or day before yesterday, I saw that Facebook, WhatsApp, these went down, but it doesn't mean that they're going down or they're crashing all the time. Maybe rarely it might happen. So your high availability thing speaks about when you host an application in their cloud platform, what is the guarantee in one whole year they give you that your application will never crash? Your scalability from one server to 100 servers or 1000 servers, you can increase your server number on demand, which is additional benefit. Excuse me. Okay, Ahmar, just let me give me a message reply to Ahmar in the chat, since they're saying that the audio is not very audible. Okay. Now, apart from that, the global reach. So from, let's say right now I'm in India, but from India, I can reach out to different countries across the globe to host my application. Agility on the other part, the proven best practices you can impose and introduced into your application development and hosting. That's the agility. Whereas disaster recovery, for giving a guarantee that even if an entire country gets, let's say, lost with all the workloads, let's say the data center of some country is crashed because of some natural disaster, still you can recover your workloads by using disaster recovery features which are supported. You have fault tolerance on the other part, where they can guarantee that even a small issue is not going to cross or crash your application. Elasticity on the other part, which could help you to easily increase and decrease the resources on demand. And then customer latency capabilities, which speaks about how do you reduce the latency for the customer with the benefits of cloud. And then predictive cost consideration. So what is the net cost that you're going to spend for all the resources of cloud you're going to use in the next year? You can predict it. Moreover, security as well, very important thing. You can get all these in the cloud platform. So how do you get that? So that's an answer you will get it when you work for each service. Every service have these benefits in one way or the other way. So you have to play with those servers in depth to get an answer. Now, what is this capex versus opex? Capital expenditure versus operational expenditure. Let's go with a simple use case. Now, I have a requirement that my customer says that he wants to host a gaming application which could accommodate 1,000 users per second all the time in one whole year. Now, what I do, I purchase a server with, let's say, to accommodate 1,000 users per second. My analysis made me to understand that I need at least 100 CPU cores and 500 GB of RAM to my server to accommodate all those particular user traffic for every single second. Okay, that's great. You decided and you purchase your 100 CPU core, 500 GB RAM, and of course you might require, let's say, 50 GPUs, graphical processing units. Maybe you got them. Let's imagine like that. Now, today you can see you get a mobile phone today. Within next month or next couple of months, you get a newer version of your mobile phone. Same way, the next particular year, if you speak about your physical hardware components like CPU core and RAM, they come with a newer version, which means when you capitally invest some money by purchasing this physical components, billions of dollars you spend and get it. Now, today you want to upgrade it, it's not possible. So you get a version 1 of so and so server or so and so physical component. It will be always version 1, even though version 10 has been launched into the market, because you have purchased it physically by paying money. So tomorrow, when you want to go to latest version, you can't achieve this, which means you have to again go to market and get the physical components, which means you are already spending money for getting the products, and it's like a investment you make in prior. So capital expenses will be higher. Not only that, now the point is that there should be a separate networking team, security team, administrative team, all these people who will manage these servers on behalf of you, which is the next big question, that how much money I'll be spending in the next 1 year for this. Whereas the next one is, that's your capital expenses will also include one more factor. Like if your customer comes and asks you that can you update or upgrade my physical components to latest version which I need, it's not possible for you to upgrade with your existing components. You will have to again repurchase the components, which means it will again require expenses to be made. So capex is one of the problem, which is when you have your own servers maintained in your office. Next, OPEX, operational expenditure. What do you mean by that OPEX? That is nothing but you use your resources, you use your workloads, you go for a scenario where you use each and every service in cloud. Let's say I use a server for 10 minutes, so I use a server for 50 minutes, so I use a server for 1 hour. It doesn't matter. At the end of the day, there should be someone, a team of people who will maintain it, where they will be using that resources for management like server management, networking management, power supply, renting of the physical location, all these. That will also become an expense for you, where apart from the capital expenses, your operational expenses will also come in your office if in case you purchase the physical components. So power supply management for the server, the rent for the physical location of your server, all these will be additional considerations you take. Whereas when you go for cloud, there is no such capex. There is no such capex. Or on the other part, there is no OPEX as well. That is your operational expenses, where a server is managed by some admin or power supply, nothing. So they have a billing unit which is already created. So you use a server of 10 GB RAM and one CPU core for 1 hour, then you pay money only for 10 GB RAM and one CPU core of the server which you use for 1 hour. Beyond that, there is no charge. So pay only for what you use, how many days or how long you use. That's a benefit of cloud. Now that's what your consumption based model is. So when you go for a cloud platform, what they are saying are that I will take care of the burden of that capital expenditure. So on behalf of you, I will purchase the servers, whatever the latest version in the market or outdated version in the market. You don't worry, I'll get it for you. I'll pay the power supply charges, I'll pay the physical rent of the location, everything I'll take care of it. So you focus only on adding the business value, which means you use the servers and services that they sell, you pay the money for total period that you're going to use those services, and there will be no charge when you're not using them. So you can clearly track your pricing, performance, and everything. Best thing is you can predict the cost, like how much you might spend if in case you use the cloud. And moreover, what is the service you're going to get, the features you're going to get. All these questions can be easily addressed. So these are some understandings you should make. So capex and opex is a question you get when you go for your own servers that are maintained in the office, whereas when you go for cloud, you will be getting the benefit of consumption based model, which you can call it as pay as you go, pay for what you use. A benefit where you pay money for whatever the components you're using and only for the time that you're using them. And the last discussion in this part, which is cloud services. So when you speak about cloud services, we are going to learn on what is IaaS, PaaS, and SaaS. What is the difference between all three, when to use which one, whose responsibility will be dealing with them, and one last component called serverless computing, which could give you questions and answers for various eye openers for cloud. The first one, IaaS or infrastructure as a service. Now, please note this. If you heard about a term called virtual machine, what is that? It is nothing but on top of your physical devices. Let's take your laptop. So your laptop or computer, whichever you are using to join to the session, it's a physical device. It will have an OS or Windows or Linux or Mac, whichever you preferably have. Now, on top of that physical device, if you want to run another virtual machine, let's say on a Windows laptop, I want to run a Linux VM, a Windows VM, and some other operating system as a virtual machine. What you can do, you can enable the virtualization tools like hypervisor. Then you can now create VMs on top of a physical machine, which means here your infrastructure is going to be your laptop, which has a hard disk, power supply, network cable. It has CPU core, RAM, and etc., which is virtually taken by a VM and using in here. So that's something you should understand. So why I'm speaking about that now. So when you speak about this term called infrastructure as a service or IaaS in cloud, it's nothing but Azure is giving you the infrastructure. What do you technically mean by that word? When I say the word infrastructure, what cloud is or Azure is saying that I will take care of the physical server, which is having a CPU core and RAM and storage, network, security, followed by the power supply, physical rent, and everything for you. So all those physical server component management, I'll take care for you. I'll give you, say for example, you need a virtual machine that is running with Windows 10 OS with 1 GB RAM and 1 CPU core. From this physical server, whichever I have, which could have, like, let's say it could have 100 GB RAM and 100 CPU cores. They will logically take 1 CPU core and 1 GB RAM for you, and they will give a virtual machine for you, which means IaaS is nothing but Azure is giving you the infrastructure, where on top of the infrastructure, you can now deploy your workloads. An example could be an Azure virtual machine, a VM that runs with operating system in it, where you start this VM, stop this VM, run your application, everything. So IaaS or infrastructure as a service works this way. Next one you have, that is PaaS or platform as a service. Now let's take an example. You want to host a website in Azure platform. So you can use a virtual machine like I discussed, which is IaaS, where you can host your website in the VM and make users to use it. Or you can go for PaaS, which is platform as a service, where what Microsoft is saying, I'll take care of the physical server and storage and security for you, and even physical power supply, rent, and everything. I will install the operating system on a virtual machine for you. I will take care of the development of the service as well. Let's say for hosting a PHP application in a server, you might require to install all the required frameworks of PHP and enable the web server as well. All these your cloud service provider they will do for you. So your OS updation of your server, which is used for hosting the application, Azure will take care of it. Starting the server, stopping the server, scaling, which means adding more CPU core and RAM, that they will take care of it. Maintenance of the server they will take care. Securing the server they will take care. Now what do I do now? You do nothing. You go with the concept, you go with a feature where you host your application, which means as a developer, my developer will develop the website and host it. He doesn't care about how the server works, who will start it, when it will get started, how the security comes to the line, nothing. So infrastructure management, you don't think about it. So you can imagine an example like GoDaddy, Big Rock. What they do, they say you pay me so and so dollar a month and I'll host your website in my platform with a domain name for you. So all your focus is now develop a website and host it, where your website management, the server management where the website is running, it's taken care by GoDaddy. They are giving that website hosting as a service for you. That's what PaaS. So in Azure we have web apps, we have we have something called API apps, we have something called API management, firewall services, many of them which are available as a service, where Azure developed it as a feature and gives you where you can use it rather than focusing on management of it. So a developer will now get more time to focus on development rather than infrastructure management. Third one, SaaS or software as a service. Very simple. The underlying physical components like virtual machine, virtual network, security, updating the OS, starting the server, development of the feature, in fact, developing the solution as well, they will take care of it and they directly sell you a term called application. They will sell you that application or a service. Excuse me. Take your Office 365 now. So Microsoft gives you the O365 services, like you can get Active Directory, security features, you can get the features like emails, you can get calendar, you can get Microsoft Teams, or you can take OneDrive, Dropbox, Google Drive, even your Outlook service. We never developed those services. We are just consumers. Either we consume them by getting a license by paying, or you consume it for free of cost. So SaaS or software as a services, in the servers of Azure, they have hosted the workload that they developed where consumers can get the license and use it. So that's what software as a service is all about, or SaaS. So for PaaS, you can take a website hosting service like GoDaddy or BigRock, whereas in Azure it's called web app. For infrastructure as a service, you can take an example like an Azure virtual machine, whereas for SaaS, your Office 365 services and all these you can take it. Next one, let's understand the comparative part of it. IaaS versus PaaS versus SaaS. So your IaaS is more flexible one because it's a server, like an example, like a virtual machine you have now. So we can decide what is the physical hardware I need, whether it's a GPU machine or it's a big data analytical machine or it's going to be a machine for, let's say, database storage. You can pick the physical hardware that you require. Followed by that, now it's a VM. So you have the choice to start and stop your VM, install any software you want, any network security internally you want to do, everything you can do. So more flexibility you get, but the management overhead you have in here because you're responsible for management. Whereas PaaS, platform as a service, in the event of this one, as I said, you focus on your development rather than focusing on infra. Moreover, the management, selection of physical components for the VM, starting, stopping the server, operating system patching, security maintenance, everything is taken care by the cloud service provider, which is your PaaS. Whereas third one, SaaS or software as a service. Nothing we're doing here. You go for free. Some features you get for free. Some features like Outlook, you take Gmail, you take it's free. Whereas you have premium options as well in that, where you can get a license and use them, where you pay for what you use, maintenance, data security, patching servers, everything they take care for you, which is your third option called SaaS or software as a service. So in Azure as well, we have plenty of SaaS components. For most perspective, we can see all these three components available in Azure. Now, for people who didn't got an answer like how these work, like IaaS versus PaaS versus SaaS, this slide can give you an answer. Now, shared responsibility model, you can say. Number one, on premises or your private cloud, where you are responsible for purchasing the physical hardware, maintaining the physical hardware for storing the data, maintaining the networking of the physical components, computer management, which is your CPU core and RAM and all these computer physically you have, you manage it. Now, on top of the computer, you deploy a virtual machine which you manage. You install the OS, update the OS, patch the OS, you start your server, you deploy your application, and you manage the data and the application access. Everything, it's your responsibility. Around 4 to 5 different teams will together work on one single environment in this case. So you can now imagine how many operational expenses you have. A developer, an architect, an administrator, a network engineer, an IAM team, everyone will get paid for what they do. Now let's go with the second one. IaaS, that is infrastructure as a service, where I gave an example as a virtual machine. Now see, Azure will take care of the physical storage, the network management, the computer, the physical computer deployment, and fixing that in the data center with power supply, everything Azure will do for you. Now, as a customer, you go to Azure and ask them, hey, I want your Azure services to be used. The moment you say this, they will create a virtual machine with whatever the desired operating system you ask, whether Windows, Linux, whatever the supported one they have. You ask it, and they will create a virtual machine for you and give it to you. So practically, it's you who create it, but the logical factor is that there are softwares that are creating the server on behalf of you and giving it to you. Now, this virtual machine, for the first time alone, it comes with an OS installed with whatever the version you pick up. But after that, you are the one who is responsible for updating the OS, which means if you speak about who's going to install the latest security patch, either you can ask Azure to install it if you want, or you can take the complete control where you can install which security patch you want to install. And moreover, it's completely you're responsible for the security of operating system and everything. Now, runtime, that is starting and stopping your server, you can do it. You have the full freedom where you can start and stop the server whenever you want, restarting everything. Hosting the application. So if I want to host an application of Python, you can host it because you have the complete freedom, as you can install whatever the tools it requires and everything, because you can connect to your server. Now, data and access. So you can now deal with how and what type of data to be maintained in my server, and how the people can access my application, whether on a port 443 or port 80, how it is, you can take complete control. So your physical server maintenance, networking, and virtualization, you don't have that burden. You only focus on a virtual server management, which is a benefit of, let's say, an infrastructure as a service, which is a virtual machine. Let's say the next one, the web app, which is a platform as a service or PaaS. In this one, you can see from the physical storage to networking to compute to a virtual machine to OS updation to runtime, where you start and stop your server. Until this, it's completely out of control. You don't manage anything. You go a little higher, which means starting and stopping the server, operating system patching as well, you don't have to do. The service which is Azure given to you, which could be a web app, SQL Server database, Cosmos DB, any PaaS component they give, they will take care of these. So you as a user, if it is a DB service, you focus on your database deployment and access. If it is a website hosting service, then you focus on hosting your website and data and access. You don't focus on server management, which gives you utmost benefit of management of this underlying server. That's next part. The third one, SaaS. Nothing is in your hand. Complete application management to server management service is taken by your cloud service provider. Whereas your data and access, that is whatever the data you feed to the application and accessing the application, is what in your hand, which is the SaaS model in here, software as a service. Now, the reason I'm giving this to you to understand how these three, like IaaS, PaaS, and SaaS works for you versus your on-prem, you should have an idea. And that could become one of the reasons why you can go for cloud. Now, serverless computing, what do you mean by that? Apart from this IaaS, PaaS, and SaaS, there is a concept called serverless computing, which means I'll say like this. I will develop an application, let's say a piece of program or a logic, but I don't want to take care of scaling. What do you mean by scaling? So in this PaaS, if you take a web app where you host a website, you're responsible for mentioning the RAM and CPU code that you need, and how the RAM and CPU code gets increased and decreased. All these, it's your responsibility to mention it. That means you are responsible, at least in a part of scaling your server in PaaS. Whereas software as a service, it's completely developed tool, so you don't need to scale the physical components like CPU core and RAM. But let's say, what if we have a workload which needs a benefit where you don't have to have a overhead of managing the CPU core and RAM. I don't want to say that I need 10 CPU cores, 1 GB RAM, nothing. There comes one user, then for one user who uses my application or my piece of program logic, what is the amount of RAM and CPU core required? It should get allocated on demand. Once the job gets over, there should no charge for this program that I wrote. If there are 1 million users, then for 1 million users, how much RAM and CPU core required? Allocate it on demand. Once the job is over, you should remove it and there should be no charge. So that's what your serverless computing is all about. So serverless computing is a concept where you don't manage your scalability like CPU core and RAM you require. You don't mention it. You only focus on developing the concept. So for that, there are services like, let's say, Azure Functions we have. These are services by Azure. You have Azure Logic App, two different services. So functions are typically piece of program you write, which could execute a business logic for you, where you don't focus on maintaining a server for running this program. On demand, the CPU core and RAM to run this program gets allocated, and once the job is over, the CPU core and RAM gets removed. That's what Azure Function is. You can run APIs or any business logics in it. Whereas Logic Apps, so Logic App is also same way. On demand, when there is one user or 1 million users, it will allocate the CPU core and RAM. And once the job is over, it will release it. Normally, Logic App is for non-developers, whereas Azure Functions are for developers who develop business logic. Whereas Logic App is for orchestration, like automating some tasks, starting some servers on demand, stopping some servers on demand. Excuse me. So sending some email notification for some business process automation or data feeds or data integration on demand. So anything that is regarding to integration, you can use this Logic Apps, especially for non-developers and various other integration services that require a serverless component, you can go for it. So if you heard about a BizTalk server in any case, that's nothing but the Logic App which is given here, where a BizTalk server, if you go for, it's you who responsible if you manage the server, which means you are responsible for maintaining the BizTalk service in the server and everything. Whereas Logic App is something which is equivalent to that, where Azure is giving you as a service, so you use it and you pay for what you use. You don't manage the underlying physical components. So that's what the serverless components in here. So that was a small walkthrough about this module, which is about what is your public and private and hybrid cloud, and then what is the concept of high availability, elasticity, and disaster recovery. What is your IaaS, PaaS, and SaaS, and shared responsibility model, which I discussed. So now, if you have any more questions with the first module, which was just a theoretical one, you can mention that before I go to the next one, which I'm going to discuss about. I can see some questions.